start numbering.
It'll help with like learning how to remember, learn how to start stuff.
Because if you can't number, you don't know where your number's gonna be all
That's entirely what it is. So, first things first is we try to figure out what our parent chain is. I also it's been a long time since I'd done stuff like this, so I had actually checked with Pelfrey, and so he said in terms of looking at this end of the structure, which is the closest to this double bond, so you're gonna have one somewhere over here. So the idea is, do you want to start with one here or one here? A lot of people see this and they think that's the isopropyl group, and they think, okay, cool, I'm not going to include that because that's just a substituent. But the idea is, if we took this structure and we moved it, or whatever, I'm going to use the red marker again to redraw this, you could rotate that and that would be your isopropyl and this is your ethyl group, right? So some of it kind of requires being able to look at your structures and know how to like rotate it in your head. But I'm going to draw it out how it's on our practice problem so that people kind of understand like thought process looking at it with the way that Dr. Pelfrey had it on our thing.
Oh, that's the one. Why won't you put number one where that first double bond starts?
Because this is the whole chain. So you don't just start with a double bond of one here, because you still have carbons that are on a chain in a different direction, right?
I'm sorry. So you can start at the bottom, or you can start on the right, or
you can start either one. You can make carbon number one here, or carbon number one here.
Okay.
So the idea is that you need to then look and see what substituent groups you can identify. So we can't just start with parent chain on this one. We actually have to look at substituents that we can identify. So I always start with the ones that are the easiest. So here is a methyl group, here's a methyl group, here is a methyl group, and then if you use this one, this is an ethyl. If you use this one, then you have this as being a methyl group, methyl, or if you do this whole thing, it's an isopropyl group, if you're starting from here. So the idea is you're trying to have the most substituents on the chain that you can have. So if you start here, you get 1, 2, 3, 4 methyl groups and 1 ethyl group. So 1 ethyl plus 4 methyl groups, which is a total of 5 substituents. If you start with this being your number 1, you have 1 isopropyl group and then only 1, 2, 3 methyl groups. So 1I plus 3M is only 4 substituents. So the idea is that you want to have the most substituents that you can have, so you actually want this chain when you're looking at this.
Sorry, can you run through those again, like counting them out?
So
if you go one way or the other.
So since we just talked about this one just now, so if you start here and you go 1, 2, 3, 4, all the way down your chain, right? You have 1 isopropyl group.
Okay.
If you're using that as your parent chain.
Mm-hmm.
So this we would say is an isopropyl, and then we'd have 1, 2, 3 methyl groups if we're counting this as an isopropyl.
Mm-hmm.
However, if you're counting this as your parent chain, then you have 1, 2, 3, 4 methyl groups, right? And then you have an ethyl group. So the idea is...
Do that again? If you count, where does your chain start on that last scenario?
So if your chain is starting here,
okay,
then you have a methyl group here. It can start here too. It's just the idea that one of these is a methyl.
Got it, okay.
And the other one is part of the parent chain.
Okay.
So you're ignoring this piece right here, because these are technically the same length. So you can start with either one. It's just the way that it got drawn out makes people think, oh, well, this is on the horizontal, so this is what you start with. But that's not always the case. The other way he could have drawn that would be is if he kind of drew it in a circle, and he had like the ethyl group off of the circle or something like that, and you have to be able to understand that you could start from different positionings or whatever.
Okay.
Does that make sense?
Yeah.
Okay. So the idea is that if we start here, we get 5 substituents. If we start here, we get 4 substituents. So we want the one that's going to give us the 5 substituents. So we're going to start with this one as being our number 1 carbon. And like I said, it could be either one of these two. It doesn't have to necessarily be this one on the right. I'm right-handed, so I go to the right. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, and then same thing on this one. You could go either one being your number 10, but I like to try to stay in the horizontal just because that's what I like to do. So I'll make that 10. Okay. So then it comes down to, okay, cool, we've got our primary chain, we've got our parent chain. And we know that this is dec, because it's 10. And then we've got the idea that there are these double bonds here, which makes it an ene group. But there's more than one double bond, and they're not on carbon 1. So therefore you have to specify where those double bonds are in terms of just the first carbon. So you don't have to put 3, 4, you just put 3 for that first one. And then for the second one, it starts at 6. So it's 3, 6, ene. So dec 3, 6, ene. That is our parent chain. The next thing we need to do is identify where our substituent groups are. So once again, we've got this methyl, this methyl, this methyl, and that methyl, and this ethyl, right? So we just want to identify where all of those are. So we've got a methyl at 2, we've got a methyl at 5, we've got a methyl at 8, and we've got a methyl at 9. And then basically you say, okay, well I've got 4 methyls, so then we go through our nomenclature information, which is for like whenever you have multiples. So 1 is mono, we don't really ever use mono for any of this type of stuff, but then you got di, tri, tert, right? Because tert is 4, or tetra, sorry, tetra. So tetra methyl. And then we've got an ethyl off of 3.
That would be the second butyl.
Alright, so we've got the main part of our chain, of our naming right here. So now we have to identify our chiral centers. So we've got a chiral center at 5 and a chiral center at 8. So we'll say at 5 we have something, and then at 8 we have something. Something that you could do is just go ahead and draw in your hydrogens instead of doing it the way I did it last time, of leaving it towards the end. But that way you have those drawn in initially. Some people like to do it that way, some would do it this way, just so you have an idea of where those are to start with. So that way you can have all of your information to start with. I don't typically do it that way, but I know people who do. So I'm gonna do it that way for this one. Gives us the idea of, okay, we have somewhere to start. So I still like to go in order, so I always just start with the first one that's there. So at this 5th carbon, we've got, 4 bonds. We got 1, 2, 3, 4, so we know what we're looking at. And then we look at our carbons. So, or at our numbers for our carbons. So H is always spot number 4. And then we look at this carbon, and this carbon, right? Because this is CH3. And then this carbon has 1, 2, 3 bonds that are not hydrogen. This carbon also has 3 bonds that are not hydrogen. 1, 2, 3. Between this carbon, this carbon, and this carbon, we know that this one is the lowest priority because of the fact that it just has hydrogens attached to it. So we can automatically give this spot number 3. The next thing is we don't really know which of these has higher priority of these two at the top, right? because they're both carbons with 3 bonds. So we just move out. So we move out to here, and so we're looking at this carbon and this carbon. Looking at this carbon first, we see that we've got 1, 2, 3, 4 things bound to this carbon, right? That are not hydrogen. This carbon has 1, 2, 3 things bound to it. So this one has more things bound to it, so that makes this spot, this bond here, priority number 1, which makes this automatically priority number 2. Right?
Say that again?
So this one has 4,
Yep.
so that makes this priority number 1.
Mm-hmm.
This one is automatically priority number 2 because we already determined 3 and 4. So then we look at this and we see the rotation. And we see that it's counterclockwise. With the idea that, okay, it's counterclockwise, so that should make an S, but this hydrogen's on a wedge. So we convert that to R. So then we know that this is 5R. And then keep moving out, and then we look at our next chiral center. Okay? So we're looking at this with the idea that hydrogen's all automatically 4. And honestly, if you ever see a methyl group, CH3, that's probably 3. Just the fact that these both have bonds here automatically tell me that this is gonna be number 3. It's not always, but for the most part, if you see a methyl group, it's almost always number 3. Just because I'm trying to cut down on time. These two, though, we have to look at how many bonds they have. So looking at this carbon, we already did this previously, we saw that that had 3 bonds. And then looking at this carbon right here, we see that that one also has 3 bonds. Kind of same thing as we did before, you move out, doesn't really matter which way you move. I try to move to whichever way has more bonds if I have a split. These are the same, so it doesn't really matter. We know that this is CH3, so it literally is just the 1 carbon bond here. And then we look at this one, and this one has 3 carbon bonds here. So this one has priority for this specific chiral center. So then this is 1, and this is 2. So then this is going clockwise, which is an R, and the hydrogen is on a dash, so stays an R. So R. Now, a lot of people stop right here and they forget that we've also got double bonds in a linear structure. So anything that is a linear structure, we need to identify double bonds if they are a stereocenter. So, which pretty much anything in a linear structure will have a stereocenter because it has that ability to rotate. That's what the idea of a stereocenter is that ability to rotate. So I know there's a bunch of crap drawn on here, so I'm gonna erase it to make it a little bit easier for people to see now that we've kind of like already identified all of our other stuff. Try not to erase all my other stuff that I've written down. Go and erase that. Alright, so I'm going to look at this, which is 3, and I'm going to look at 6 here. That's where our double bonds are. We do it according to whatever the first carbon is how we label that. So it's going to be at the 3 spot and the 6 spot. So first thing I'm going to do is I'm going to split this double bond looking at each side. So looking at each side of this, I can see that this side over here only has a thing with a carbon here, and then basically a hydrogen here that's not drawn in, right? So this carbon has priority compared to that hydrogen, so we know that this side is our priority group.
Are you doing the ZE thing right now?
Yeah.
ZE,
Yeah.
yeah.
Okay.
Okay? So then the other side I'm looking at is I'm looking at this side over here of that double bond, and I'm counting how many carbons I've got. I've got 2 here, 1, 2. I've got 3 here, 1, 2, 3. So this is priority, right? Because 2 carbons versus 3 carbons for like what's on this side of it. So then this is my priority. So then I draw my little imaginary line through this, and I say, oh cool, both of these priorities are on the same side. So what does that make it?
Z.
Z.
The same side.
Yeah, zeta. So yeah, so that one's done. Now we move to numero 6. This one's a little bit easier because you can kind of just look at it. It kind of just looks like they're on opposite sides, right? You don't really have to do too much, but if you wanted to, you look at it and say, okay, cool, I got the same thing where this is my priority group on this side, and this is my priority group on this side. And now I see that if I draw that imaginary line, my arrows are on different sides. So that means it's E. So this is the extent of what I need for my name here, right? So now I just write this out as this is written out with the numbers for the R, E, Z, S, all this stuff. It's done in numerical order. So it would be 3Z, 5R, 6E, 8R, and that's in parentheses at the front of your thing. I just don't have very much room to write literally everything out. And then when it comes down to this, it goes back to alphabetical naming order. So
Sorry,
E
for the
is
parentheses, you don't do the E and Z first and then the R's and S's?
I always have just done it in numerical order.
Okay.
I honestly don't know if Pelfrey really cares that much. In terms of our test, I really think that it's going to be one of those things where question 1 is going to be identify your R's and E's and Z's and S's and all that. And then question 2 is going to be identify your substituent groups and like what carbons those are on. And then question 3 is going to be identify your parent chain and what the name of that parent chain would be. And then question 4 is going to be, can you identify like the full name of the structure or something like that. It's going to be a 4-part question, and honestly, you could probably throw a 5th question in there somehow that you can have you separate out, like, you know, like what are the double bonds, 1, E, and Z, and then another question would be, well, what are these in terms of R and S, and that could be 2 separate questions or whatever. But yeah, but either way, so with this, writing this in alphabetical order, ethyl is before methyl, so 3 ethyl, and then 2, 5, 8, 9 tetra methyl dec 3, 6 ene, and this is like the full name in order right there. Okay. Questions, concerns?